Okay, Assalamualaikum and hi everyone. So today I'm going to discuss about chapter 2, which is Thermochemistry. So for this topic, actually we have four subtopics. Start with 2.1 Concept of Enthalpy, 2.2 Calorimetry, 2.3 Hess's Law, and 2.4 is Born-Haber cycle. So for the first part, 2.1, you're going to learn about the exothermic and endothermic reaction, the type of enthalpy, and also the thermochemical equations. For the second part, 2.2, calorimetry is all about simple calorimeter and also bomb calorimeter. For 2.3, Hess's law is all about algebraic method, energy cycle method, and also dissolution process. For the last part of thermochemistry, you will learn about 2.4 Born-Haber cycle, which is you learn about energy cycle diagram and also about energy level diagram. So this is the overall of thermochemistry. Okay, for the first part, it is all about 2.1 concept of enthalpy, which is what we're going to see or what we're going to know first is thermochemistry. So the words thermo actually is referring to the heat, and the chemistry means is all about the chemical equations. So as we can say, the definition of thermochemistry is the study of the heat changes in the chemical reactions. So what we're going to see in this thermochemistry, so we are going to see about the chemical reaction involved of release of energy or absorb of energy. So mostly it is in the form of the heat. So energy is all about the capacity to do work, and normally is all about using the unit, which is energy is joule or calorie. Okay. So in this 2.1 concept of enthalpy, you also need to know about enthalpy. So what is enthalpy? Is all about the thermodynamic quantity used to describe heat of a system. So the unit that we use to represent the enthalpy is joule, or we use the capital J. And the total enthalpy of a system cannot be measured directly, but we can measure the change in enthalpy, which is we also know it as a delta H. So the change in enthalpy is also known as heat of reaction. So you as a student should know if we are talking about heat of reaction, it is also equals to heat is also equals to enthalpy change, delta H. So the second part of the concept of enthalpy is you need to know how to calculate of enthalpy change. So the enthalpy change that you can calculate is you have to calculate the sum of the enthalpy of the product minus with sum of the enthalpy of the reactant. Okay, and we have two type of reaction involved to in order to calculate the enthalpy change, exothermic and endothermic. So for exothermic, let's say we have the general equation here is A react with B produce C and D. So in order to calculate the enthalpy change, we need to know the product C and D, the sum of the product C and D will minus or deduct with the sum of reactant A and B. Therefore, You can see here, if it is an exothermic reaction, the enthalpy of the product is smaller than enthalpy of the reactant, which is at the end you will get the delta H equals to negative. Okay, so the heat released from the system to the surrounding, that is what happened for the exothermic. That's why the enthalpy of the product is less than enthalpy of the reactant. Okay, for the second part, which is endothermic reactions, let's say we have P react with the Q, it will produce R and S. If we want to calculate, so sum of R and S will deduct with sum of P and Q. Therefore, what will happen? Enthalpy of product is greater than enthalpy of the reactant. Therefore, the delta H will become positive. This is heat absorbed from the surrounding to the system. That's why the enthalpy of product is bigger compared to the enthalpy of the reactant. Okay. So beside we learn about the exothermic and endothermic, how to calculate the enthalpy of the enthalpy change. Here we can see about the energy profile diagram. So after we have known about the exothermic and endothermic reaction, here actually you can relate with the energy profile diagram. So as we said, exothermic, the enthalpy of the product is smaller compared to the enthalpy of the reactant. So you can see here, this is the delta H, the enthalpy which is a negative value. And here, what you can see, if endothermic, it is opposite the exothermic, which is enthalpy of the product is larger compared to enthalpy of the reactant. That's why we get here the delta H or enthalpy change is positive. So beside that, what you can see from the energy profile diagram, there is the activation energy. Okay, so in the next topic, you will get to know about the activation energy. Okay, so what is the functions of the activation energy? So the activation energy is to minimize the repulsion, or it will initiate the reaction. Okay, so that is activation energy. So we're going to see why the here you can see the peak for the exothermic. It is you can see the reactant here. Enthalpy is bigger or larger compared to the product. But for the endothermic, enthalpy of the reactant is smaller compared to the product. Okay, so hopefully you can know very well in drawing or sketching about the energy profile diagram. So don't forget to write the unit of the potential energy, which is it is joule. Okay, and against the reaction progress. Okay, so the technique used to measure the enthalpy of the reaction, this one we call calorimetry. So beside you learn about the type of reaction here, about exothermic and endothermic, you are also going to calculate whatever enthalpy of the reaction in the topic of calorimetry. Okay, next, the thing that you need to know is thermochemical equations. So normally you already well known about chemical equation, but this time around in the topic of thermochemistry, you in you also need to know about thermochemical equation. So what is a thermochemical equations? Thermochemical equation is a balanced chemical equation that shows the enthalpy change of a reaction with its value and sign written on the right hand side of the equations. Okay, what is that? Okay, first of all, what you need to know is let us look up for the first requirement. The phases physical state of all species must be specified. What does that mean? The reactant and the products are said to be in their standard states. For example, like given in the table, all metals are solid. Sodium is a solid. Lithium is a solid. Potassium is a solid. Most salt are solid because salt is normally is a ionic bond. So it is a solid. Sodium chloride, KCl, also solid. Common solid for sulfur, carbon, because it is a very common compound, like carbon is the most abundant in the earth. So we always see the carbon in the form of solid. And then group 17 is not all group 17 is a solid, but chlorine is a gas. Um, Iodine only it is a solid. Chlorine is a gas. Bromine is a liquid. Okay, this is because of the molecular weight. That's why they have a different kind of physical state. So common gas O2, N2, CO, CO2, H2 is all in a form of gas. For example, here, let's say H2O is in the solid phase, yeah, and then it produces H2O in a liquid phase. So what you can see here, normally you only see this equation, which is we call chemical equation. But now there is another important thing that we have in the equation, which is enthalpy change. So this one, when we have all this, we call it as a thermochemical equation. That's why we say a balanced chemical equation that shows the enthalpy change with its value and sign. See the value with the correct joule or kilojoule with the correct sign, positive or negative, because it wants to show it is exothermic or endothermic. So it's always on the right hand side. The second thing that you need to know about thermochemical equation, for reverse equation, the magnitude of the enthalpy change for the equation remains the same but its sign changes. Okay, let us look up for the example. Okay, let's say we take the same example, H2O. So the H2O solid to H2O liquid, at the beginning, the enthalpy change is a positive. So we understand 6.01 kilojoule of heat is absorbed when 1 mole of ice is melted. If we want to make the equation become reverse, so from H2O liquid, it becomes H2O solid. So the enthalpy change now it is not positive, but now because it reverse, it will become negative here. So what is meant by the second criteria of the thermochemical equation? So therefore here what we can conclude, 6.01 kilojoule of heat is released when 1 mole of water is freeze. Okay, so this is what you need to know which is we said if the equation is reversed, if the thermochemical equation is reversed, automatically the sign will be changed, but the values still remain the same. Okay, but we have the third criteria, which is we say if the thermochemical equation is multiplied by a factor of A, then enthalpy change must be multiplied by the same factor. If, for example, this one, okay, we take the same example. So at the beginning, 1 mole of water in the solid form will produce 1 mole of water in a liquid form. The enthalpy change is positive 6.02. But now, because of the equation right now, the coefficient is 2 mole. So each of it must multiply with 2. Therefore, the enthalpy change also have to multiply with 2 and it become positive 12.02 kilojoule. Okay, so this is what you can see based on the thermochemical equation and how it functions accordingly. Okay, so I just want to show just a little calculation just to show what is the relation in the thermochemical equation and how you're going to relate with the enthalpy change. Okay, so the question said how much heat is released when 266 grams of white phosphorus burn in air. Okay, we have phosphorus P4. It burns with the presence of oxygen and then it will produce phosphorus oxide P4O10. Okay. With the enthalpy here, enthalpy change here is negative 3013 kilojoule. Okay. So from this thermochemical equation, you must understand the relationship for each of the species inside the equation with the enthalpy here. Okay, let us see what is it. Okay, the first one. 1 mole of P4 or 1 mole of phosphorus, it release negative 3013 kilojoule of heat. And 5 mole of oxygen also is equivalent with negative 3013 kilojoule. At the same time, 1 mole of P4O10 is equivalent to 1 mole of negative 3013 kilojoule. So this is the relation that you can see. Every single species in the equation, it will have the same enthalpy change because it's referring to the same reaction. Okay, so for this question, the question said how much heat is released when 266 grams of white phosphorus burn in air. Means we need to find out about P4. Okay, but we know here, based on here, 1 mole of P4 equivalent to negative 3013 kilojoule. So let us find out how to solve the problem. Okay, so first of all, you find the mole of the phosphorus and you will get here 2.1469 mole. From there, you have to compare using the stoichiometry. 1 mole of phosphorus equivalent to negative 3013 kilojoule. But now you have 2.1469 mole of phosphorus. So how much is it? It is equals to negative 6468.6 kilojoule. So that is how you're going to find the heat release or heat absorbed in the reaction if you have the thermochemical equation. Okay. So this is just example of question that I share with you, and you can try for the next questions. Okay, so beside we have calculated about the enthalpy change, now I would like to introduce to you the difference between standard state and non-standard state for the enthalpy of reaction, or we call it as a heat of reaction. So for the standard state, and the pressure is 1 atm, and if it involves of solution, it must be 1 molar, 1 mole per liter. And if it is non-standard state, so it could be at any temperature, any pressure, and any molar solution. Okay, so this is the thing that you need to remember when we are talking about standard state and non-standard state. So hope you can get the tips from here, okay, in order you can understand better about standard and non-standard state. So for the next one is you also need to know about the type of enthalpy. So we have about 6 type of enthalpy that you have to remember. But at the beginning, I would like you to see the difference between enthalpy of formation and the difference with the standard enthalpy of formation. So this is just as an example so that you can understand what is the difference between the terms enthalpy of formation and standard enthalpy of formation. So if we have the word standard in front, so actually here it should have delta H F naught. Okay, delta H F naught. Okay, so what you can see here, the definition is the heat change when 1 mole of a compound is formed from its elements in their most stable state at stated temperature and pressure. If the definition is for standard, we change a bit at the end of the definition, which is we said the heat change when 1 mole of compound is formed from its elements in their most stable state at standard condition. What is the standard condition? We have to mention 25 degrees Celsius and 1 atm. So that's why I want you to see the difference between non-standard state and standard state. So here, this is the difference that you can see between standard and non-standard state definition. Okay. So here I give you some overview of the type of enthalpy, which is we can divide into 3, which is the first one is we call heat change. The second one is a heat absorb, and the third one is heat release. Because we have a lot of type of enthalpy, so it is easier for you if you split into whether that type of enthalpy is a heat change, heat absorb, or heat release. Okay, for the first one is heat change. What is meant by heat change? So heat change means that enthalpy, it could be become endothermic or exothermic. It can uh, absorb the heat or release the heat. That's why we say heat change. So it's not specific only for release, or it's not any specific for absorb, because not all of the enthalpy of formation will release the heat. Not all enthalpy of solution is will release the heat, but or it absorb the heat. It's depend on the reactant use. Okay. So now we're going to see the definition. If for enthalpy of formation, so the heat change when one mole of compound is formed from its elements in their most stable state under stated condition. So the definition that I give you here, it is at a normal condition, is not referred to the standard condition. That's why here I said state the most sorry, one mole of a compound is formed from its elements in their most stable state under stated condition. Okay, so let us see what is that. What is meant by enthalpy of formation. So this is the thermochemical equation that you need to know. Okay, the heat change when one mole of compound. The one mole of compound is referred to this one. One mole of compound is formed from its element. Okay, what is the element inside H2O? We have hydrogen and we have oxygen. Okay, so we have to make sure when you write the thermochemical equation to represent enthalpy of formation for this one, you have to know what is the standard ataupun its their most stable state for the hydrogen. So we understand if hydrogen is appear in the normal condition in the form of gas. That's why we write here H2. Same we goes to the oxygen. That's why when the question say enthalpy of formation, so we know we want to form water. So what is the element? Hydrogen and oxygen. So the most stable state is H2O2. And this is the enthalpy. Okay. The enthalpy is actually is very specific, and normally the value of enthalpy will be given, but you must know how to write the thermochemical equation. The next one is enthalpy of solution. So what is enthalpy of solution? Enthalpy of solution is the heat change when one mole of a substance is completely dissolved in water to form a very infinite dilution. Okay, so this is so when we are talking about enthalpy of solution, normally the substance that we are focused is substance that refer to the salt, or it is ionic compound. Okay, and when it dissolves in the water, what will happen? Immediately it will dissolve and form as an ion. That's why in the beginning it is a solid, and then when it dissolves in the water, it will form ion, which is in the aqueous phase. So every single compound, it will have its own enthalpy change. Okay, next we go to the heat absorb. So the type of enthalpy that involve of heat absorb is enthalpy of atomization. What is enthalpy of atomization? The heat absorbed when one mole of gaseous atom is formed from its elements. So let's say we have example here, a metal which is sodium. So sodium is a metal, and at the same time it will atomize, and then it will form as a gas. Okay, this process, if you see like this, normally you can see in the topic of bond, Haber, cycle 2.4. Okay, so if you see from solid to gas, This one also we say sublimation. But for this one, we are more on saying this is enthalpy of atomization. So actually is for metal, only for metal, it can be sublime, or we can say enthalpy of atomization. Okay. And then we have heat release. There are three type of enthalpies that involve of heat release: enthalpy of combustion, enthalpy of neutralization, and also enthalpy of hydration. Enthalpy of combustion, the definition is the heat release when 1 mole of substance is burned completely in excess of oxygen. Okay, so one of the hint here that you need to understand is the substance must react with the oxygen in order it can form combustion. Okay, so for this case we have carbon. So our 1 mole of substance now is carbon. So when you write the equation for enthalpy of combustion, it is a must. It is 1 mole of the substance, and then react with the oxygen and completely burn, and it will produce CO2. And this is the enthalpy. Okay. So the next one is enthalpy of neutralization. So the heat release when 1 mole of water is formed from the neutralizations of acid and base. So this is example, which is you have to make sure when you write the thermochemical equation, the water it must be 1 mole. When you balance the equation, it should be 1 mole. So other than that, it could be 1/2 and so on. It doesn't matter. But why it become like that? Because of we want to relate with the meaning of enthalpy of neutralization. Same with other enthalpy. Uh, Whether it 1 mole, you have to refer which one is given. Okay. So the next one is enthalpy of hydration, the heat release when 1 mole of gases ion hydrated in water. So 1 mole of gases ion. So this one is it must be 1 mole. Okay, 1 mole of sodium ion hydrated in water to form here sodium ion in aqueous phase. Okay, so hope all of you can understand, try to figure out more about what the type of enthalpy, okay, and how to write the thermochemical equation for each enthalpy based on definition. Okay, so we move to the second part, which is this is 2.2 calorimetry. So for calorimetry, the words calorimetry it shows that method used in the laboratory to measure the heat change of a reaction. So for 2.1, we already get to know a bit of this enthalpy change. Now we go more further on how to calculate. Okay, so the device that we use in the calorimetry is actually calorimeter. Okay, but you have to know we have two type of calorimeter. One is we call simple calorimeter. Second is bomb calorimeter. Okay, so here I would like to introduce to you a bit of the device of calorimeter. So the first one is simple calorimeter. So simple calorimeter also known as constant pressure calorimeter. So the words constant pressure calorimeter mean the pressure is constant and it won't change. And this is calorimeter, which is it is at constant volume. Okay, so for simple calorimeter, you can see outside of the calorimeter is only a coefficient. We call it as a polystyrene. Okay, but this is inside, which is it has a solution, and you can see the thermometer. This one we call has the stirrer. Okay, so this is how it will function. Okay, and the other one is bomb calorimeter. It is more complicated compared to the simple calorimeter, because this one the equipment is complex, and it involves of the type of reaction like combustion, combustion. Okay, that's why we use bomb calorimeter. Okay, for simple calorimeter, the type of reaction involved is neutralization. We can use for solution and also for hydration. And for type of reaction involved in bomb calorimeter is combustion, okay, or formation. So the more complex the reaction, that one we use the bomb calorimeter. But for simple calorimeter, we use duration that it is only can be mixed in the lab, in our lab, which is like neutralization of acid and base, where we do these two acid and base mix together, we can neutralize, get the salt. Okay, so that's why we call simple calorimeter. Okay, so another thing that you need to know about the calorimetry is about the heat capacity and also specific heat capacity. So heat capacity and specific heat capacity both are referring to it can be referring to the same material. Okay, but what is heat capacity? Heat capacity we represent with capital C. So we go to the definition. Heat capacity is the amount of heat required to rise the temperature of a sample of a substance by 1 degree Celsius, and the unit is joule per degree Celsius. But for specific heat capacity, it is we are using the symbol is small c, and the definition is specific heat capacity is the amount of heat required to rise the temperature of 1 gram of a substance by 1 degree Celsius. So the unit used is joule per gram degree Celsius. Okay, so make sure you know if we have the question, what the information given, is it refer to the heat capacity or it refer to the specific heat capacity. Normally in our topic of calorimetry, the heat capacity is always referred to the heat capacity of calorimeter. And for the specific heat capacity, normally we are referring to the water or to the metal. Okay. So I just give you the basic principle of calorimeter. So after this, you can go through yourself about the basic principle of calorimeter. Heat released by the reaction is always equals to the heat absorbed by the surrounding. Okay. So what is the reaction? Heat released. It is referred to the chemical reaction involved in the calorimeter. Okay. And then what is the surrounding? depend on the condition. Sometimes it could be calorimeter, or maybe water or solution, or maybe calorimeter and water, or maybe calorimeter and solution. So this is all the thing that uh, you all need to know for the topic of 2.1 and 2.2, the basic knowledge about enthalpy and also about the calorimeter. So hope with this brief explanation of the chapter 2.2, you get some idea how to uh, some idea in understand about the topic of chemistry. So hope you enjoy the lesson and thank you.